Hi there S6, hope you had a lovely break and a nice time off from school last week. We're going to start this session of practicals by trying to do an experiment to determine the mass of a small cardboard disc that you should be able to cut out from packaging at home. It's corrugated, ideally slightly corrugated card, so quite a thick card, but it doesn't have to be overly thick. It must be around about 10 centimetres diameter. 9 is okay, but I wouldn't go less than 9 because you won't be able to get the coins in suitable positions, and you can go a little bit more than 10. I can't see any reason why it wouldn't work with 11, 12, even 13 centimetres. So all you need is some object that is around about 10 centimetres, so for example a mug, a little plate, a compass will be able to give you a nice circle, anything like that. If you don't have anything really suitable to hand, you can always use a roll of sellotape. Unfortunately, it's not always perfectly circular, it tends to get a bit squished. But if you really have nothing else, that would do, which is also just over about 9 centimetres. So we're going to determine the mass of this piece of card, and we're going to do it by attaching some pound coins or 1p coins or 5p coins, ideally quite small coins, to the circular disc at different positions. You'll see that you need to mark on lines that are going at 60-degree angles to each other. So you're marking out positions at 120 degrees. You only really need the 120. I've put on the 60 just to make the line the whole way across, but you really need three lines marked. And then additionally, you might see that I've got half centimetre positions marked as well. And this is to enable me to place the coins where I want them to be as accurate as I can. Obviously, we're not looking for a huge degree of accuracy, but you need to note down what your uncertainty is, and that's going to come and play a part when we go on to determine the mass. So the basics of the experiment, I'm going to show you it later on properly set up, but the basics of the experiment is that if I have two discs and I've got them taped together with 3 bits of thread, the thread should be roughly 0.5 metres in length, give or take. The important thing is that you're trying to keep it as horizontal as possible when you're doing the experiment. Now that may be difficult to achieve. Again, I'll maybe give you some tips later on when I'm setting that up to show you the best way to do that. And the idea is that you won't be holding this by hand when you do the experiment. You'll be having this on a stand, so it's kind of clamped in position. But the idea is that if you give this a little bit of a twist and release it, you'll see it's got a rotation and it's got a certain period associated with it. And that's to do with the moment of inertia of the disc combined with the moment of inertia of the coins that have been placed on the disc. If I move these coins so that they are closer to the centre, I'm changing the moment of inertia of the whole system. And you'll see that by changing the moment of inertia, I also change the period. So if you roughly think about how fast that one was, if I put all 3 coins at the very centre, and I found that blue tack is the best thing for sticking these. Sellotape, it tends to just be much more fiddly. So if I put the coins now at the centre and do the same experiment, you'll probably notice that the period of spinning is much quicker. Okay, so its period of oscillation depends on the positioning of the coins about the cardboard disc. And our experiment is going to be measuring that period of oscillation as a function of position of the coins. So we're not actually going to start with them at the centre, we're going to start with them positioned around about 1.5 centimetres out from the centre. So that's why you need your marking. So you're going to put your marking and place the coin such that the centre of the coin is sitting 1.5 centimetres from the centre of the cardboard disc. So kind of roughly like that. You'll then let that oscillate and time that for 20 oscillations so that you get something more accurate to work with. So obviously then you can divide by 20 to get the period of oscillation. If you just tried to use a stop clock to get a single oscillation, it would be quite inaccurate. So you get the period of time for 20 oscillations. You'll then move all the coins out by 0.5 centimetre and then repeat and keep going different distances from the centre, and get a table of your period as a function of the distance of the coin from the centre. Okay, before you start the experiment, two things you want to measure are the radius or diameter, to get the radius of the cardboard circle that you've cut out. And remember, you need to note down your uncertainty, so note down the reading uncertainty from the ruler that you're using. You may be able to look up a calibration uncertainty, which you might want to use later as well, but that's not so essential. And the other thing you need to determine is the mass of the coin. I appreciate that's probably going to be quite difficult for most of you to determine this experimentally at home. Some of you might have kitchen scales, such as this spoon, that allow you to measure it quite accurately. So if I do this as a pound coin with a tiny bit of blue tack on it, and again you want ideally the measurement with the blue tack as well, because it's the mass of both of them together. So this is telling me it's about 8.9 grams. But if you don't have this kind of measuring spoon, which probably a lot of you don't, remember you can just look up the mass of a £1 coin or a 5p coin or a 1p coin on the internet, and obviously it doesn't have a little bit of blue tack attached, but the blue tack is negligible, so it's fine to just get that. So if I looked up online what is the weight of a £1 coin, it tells me the mass is 8.75 grams, so you can see my own measurement and the one on the internet are in quite good agreement. The only advantage for measuring yourself is that then you can use the uncertainties in your measurements, your measurement uncertainties. But if you have taken it online, you will still get an uncertainty possibly in the data source you use, or if not, remember, if it's only quoting it to 8.75 grams, for example, it's quoting it to the nearest 10 milligrams, so that's going to be my uncertainty. Okay, so once you've done that, the next thing is to create your setup, where you need some kind of clamp stand, but obviously you won't have a clamp stand at home. So there's various solutions, you can be creative, come up with something. All I'm using is 2 chairs and then a kid's mop that's going to clamp this setup onto it, so that this will then hang in the middle. And I'm going to use sellotape to secure this end, and to secure it here in the centre. Okay, so having secured my top card, I then want to check if it's lying horizontally down at the section where I've got my coins. And from this I can see it's not really quite exactly horizontal yet. I would say that this line is a bit, this length of string here is slightly too long. I'm not expecting you to determine with a spirit level, but just approximately trying to get it as close to horizontal as you can. So what I would do here to shorten this is just take off the tape where I've taped that bit of string on, and just move the string down slightly and retape it so that the string is just maybe a millimetre or two shorter. I'd keep repeating that until I'm happy that the whole setup is as level as I can make it. Okay, I've now readjusted and I'm pretty happy that this is more or less level. So then the next step, all I'm going to do is rotate the setup slightly with a stop clock in one hand and rotating it with my other hand. I'm going to rotate it by approximately 60 degrees. So to about here, and then I release and start my stop clock and time how long it takes for 20 oscillations. Ideally, I don't want to be swinging side to side. You can see it swinging a bit side to side here. You may want to repeat a couple of times so you are quite happy you can get it with as little sway as possible, but I wouldn't expect you to be able to eliminate all sway. So again, don't worry about the fact that it's moving a little bit left, right, etc. at the same time as it's spinning. Okay, so then you record your time for 20 oscillations, you divide by 20 and you have your period, and that's as a function of x, where x is the distance from the centre of the cardboard to the position of the centre of the coin. Okay, so again, try and measure and determine that as accurately as you can, noting down the uncertainty in the measurement that you take. Okay, hope that was clear enough that you were able to perform the experiment today. The setup is probably what takes the longest, cutting out the cardboard, setting up it onto some kind of clamp stand, that kind of thing. The actual experiment itself should only take you 15-20 minutes to perform, because it takes about 20 seconds or so for your oscillations. You're timing that, recording that, and then repeating that 5 times for 5 sets of measurements. So just to recap, the aim of the experiment is to determine mass, but we'll do that in a future week. But for what you need to do today is to find how the position of the pound coin, where you stick them, position of the pound coin, you'll try it at different positions, affects the period of oscillation. So you should have a table which has your independent variable, which is your x value, your position of the coin, and your period of oscillation. And if you want, at the end of this Firefly page, you'll find a bit of the background theory. So try and have a wee look through, see if you follow it, if you've got time. But don't worry if you found it a wee bit confusing, because we're going to go through that a little bit in our live lesson on Monday, and then explain how you're going to use the background theory and your data to plot a nice straight line graph, and then be able to determine gradient, intercept, and finally the mass of this this cardboard circle. Okay, so good luck. If you do have questions, remember you can always fire a message on Teams to myself if you're in my group on Friday, or Mrs. Walland if you're in her group on Thursday. And just good luck with trying to get a good set of data. Okay, see you soon.